Welcome to solving an IVP with piecewise continuous forcing function. So recall, if we have an IVP, we can take the Laplace transform of the equation using the fact that if the Laplace transform of y of t is equal to capital Y of s, then the Laplace transform of y prime of t is equal to s times y of s minus minus y prime, y of 0. So the Laplace transform of y prime of t is equal to s times y of s minus y of 0. And the Laplace transform of the second derivative of y of t is equal to s squared times capital Y of s minus s times y of 0 minus y prime of 0. And then we can use the inverse Laplace transform, or we can solve for capital Y of s and then use the inverse Laplace transform to solve for y of t. So then we can solve for capital Y of s and find the inverse Laplace transform to find y of t. And previously, we had just continuous functions that were not piecewise as our forcing functions. But now we have the ability and the technique to take the Laplace transform of a piecewise function as well. And so we can now solve IVPs where the forcing function is piecewise. So let's go ahead and consider the IVP y double prime minus 3y prime plus 2y is equal to f of t. With the initial conditions y of 0 equals 1 and y prime of 0 equals -2. And where that forcing function f of t is equal to 2 for t between 0 and 5 and equal to t for t greater than or equal to 5. So what we get then is we have that f of t is equal to, technically we have used 0 if we want, but we can just use 2. And then plus, we would have u of t minus 5 times, we need to subtract off the 2 and then add on our new target of t. Or in other words, f of t is 2 plus u of t minus 5 times t minus 2. And this is for t greater than or equal to 0. So we are working with y double prime minus 3y prime plus 2y is equal to 2 plus u of t minus 5 times t minus 2. And then we still have our initial conditions of y of 0 equals 1 and y prime of 0 equals -2. So we need to take the Laplace transform. So we have the Laplace transform of y double prime minus 3 times the Laplace transform of y prime plus 2 times the Laplace transform of y is equal to the Laplace transform of 2 plus the Laplace transform of u of t minus 5 times t minus 2. If we set Laplace transform of y of t equaling capital Y of s, then we have a Laplace transform of y prime is equal to s times capital Y of s minus lowercase y of 0. That was equal to 1. So we have s times capital Y of s minus 1. Laplace transform of y double prime is equal to s squared times capital Y of s minus s times y of 0 minus y prime of 0. So this becomes s squared times capital Y of s minus s plus 2 if we plug in y of 0 equals 1 and y prime of 0 is -2. So our equation now becomes, so plugging into the equation, we wind up getting s squared times capital Y of s minus s plus 2. And we have minus 3 times s times capital Y of s minus 1. And then we have plus 2 times capital Y of s. This is all equal to the Laplace transform of 2 is just 2 over s plus the Laplace transform of u of t minus 5 times t minus 2 would be e to the -5s times the Laplace transform of g of t plus 5, where g of t is t minus 2. So if g of t is t minus 2, we have that g of t plus 5 would be t plus 5 minus 2, or t plus 3. And so the Laplace transform of g of t plus 5 is the Laplace transform of t plus 3. Laplace transform of t is just 1 over s squared. And then Laplace transform of 3 is just 3 over s. So rewriting that entire equation we had before, I'm going to go ahead and combine my terms. We have s squared minus 3s plus 2, all of that multiplying our capital Y of s. Then we have a minus s plus 2 and a plus 3. So we have a minus s plus 5. And then on the right-hand side, we should have 2 over s plus e to the -5s times 1 over s squared plus 3s. So we have 2 over s plus e to the negative 5s times, in parentheses, 1 over s squared plus 3 over s. So we have capital Y of s is equal to s minus 5 plus 2 over s plus e to the negative 5s times 1 over s squared plus 3 over s, all divided by s squared minus 3s plus 2. Now you can see our partial fractions come into play. So at this point, we need to rearrange. Okay. So at this point, we need to rearrange into recognizable form. So we have capital Y of s is equal to s minus 5 over s minus 2 times s minus 1 plus 2 over s times s minus 2 times s minus 1 plus e to the negative 5s times 1 over s squared times s minus 2 times s minus 1 plus 3 over s times s minus 2 times s minus 1 I'm going to go ahead and just combine together that first two fractions, and then I'll combine together the two fractions being multiplied by e to the negative 5s. So this is, we would have s squared minus 5s plus 2 all over s times s minus 2 times s minus 1. And then plus e to the negative 5s times 1 plus, we just need another 3s in that second fraction, so 1 plus 3s, all divided by s squared times s minus 2 times s minus 1. Now I'm going to do two sets of partial fractions. So we'll focus on this s squared plus 5s plus 2 over s times s minus 2 times s minus 1 first. So s squared minus 5s plus 2 over s times s minus 2 times s minus 1. We can split as a over s plus b over s minus 2 plus c over s minus 1. Or s squared minus 5s plus 2 is equal to a times s minus 2 times s minus 1 plus b times s minus 1 plus c times s minus 2. If I plug in, or if I set s equal to 0, then we wind up getting 2 is equal to a times negative 2 times negative 1, or 2 is equal to 2a, and so we get that a is equal to 1. If we set s equal to 2, then we are looking at 2 squared minus 5 times 2 plus 2 is equal to b times 2 times 2 minus 1 would be 1. And so we have 4 minus 10 plus 2 should be a negative 4 is equal to 2b. And we get therefore that b is equal to negative 2. If we set s equal to 1, then we have 1 squared minus 5 times 1 plus 2 is equal to c times 1 times 1 minus 2. So c times 1 times negative 1 1 minus 5 plus 2, we would be looking at -2 is equal to -c. And so we therefore get that c is equal to 2. So we have a is 1, b is -2, and c is equal to 2. So we have that our s squared minus 5s plus 2 over s times s minus 2 times s minus 1 is equal to, our a was equal to 1, so we had 1 over s, then minus 2 over s minus 2, and then plus 2 over s minus 1. So that's figuring out the partial fractions for that component. For our other component, we had a 1 plus 3s over s squared times s minus 2 times s minus 1. So 1 plus 3s over s squared times s minus 2 times s minus 1. We should be able to write this as an a over s plus b over s squared plus c over s minus 2 plus d over s minus 1. So we have 1 plus 3s is equal to, we have a times s minus 2 times s minus 1 plus b times s minus 2 times s minus 1 plus c times s squared times s minus 1 plus d times s squared times s minus 2. I need to update my screen. And we have 1 plus 3s is as times s minus 2 times s minus 1 plus b times s minus 2 times s minus 1 plus c times s squared times s minus 1 plus d s squared times s minus 2. So if we set s equal to 0, then we have 1 is equal to b times -2 times -1. So we get 1 is equal to 2b, or b is equal to 1/2. If we set s equal to 2, then we are looking at 1 plus 3 times 2 is equal to, the only term without an s minus 2 is the c term. So that should be equal to c times 2 squared, and then times 2 minus 1, or times 1. So we have 7 is equal to 4c, and we get c is equal to 7/4. If we set s equal to 1, we are looking at 1 plus 3 times 1 is equal to, the only term without an s minus 1 is that last one. So we have d times s squared times s minus 2. So d times 1 squared times 1 minus 2 is -1. And this becomes 4 is equal to -d, or d is equal to -4. The only one we have not yet solved for is a. So we can go ahead and solve for that a if we wish. by either just plugging in all of our numbers and then plugging in one other thing. So we know that we have 1 plus 3s is equal to a times s minus 2 times s minus 1. Our b is 1/2, so plus 1/2 times s minus 2 times s minus 1. Our c is 7/4, so plus 7/4 times s squared times s minus 1. And then minus 4 times s squared times s minus 2. We can focus on whatever term we want. If we focus on, say, the cubed form term, so focusing on the cubed term, we have blah, 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 plus 0s cubed should be equal to as cubed plus 0s cubed from that second term plus 7/4 s cubed minus 4s cubed. So we have 0 and then plus a bunch of other stuff. So we have 0 should be equal to a, and then we have minus 4 plus 7/4. So that would be minus 9/4. So 0 is equal to a minus 9/4. We therefore get that our a should be equal to 9/4. So we have that our 1 plus 3s over s squared times s minus 2 times s minus 1 is equal to 9/4 over s plus 1/2 over s squared plus 7/4 over s minus 2. And then plus or minus 4 over s minus 1. At this point, we can go ahead and do our inverse Laplace transforms. I'm going to go ahead and do the inverse Laplace transform component of this IVP in another video. So I'll stop here, and the next video we'll finish solving this IVP. So again, we'll finish in the next video.